We are going to do a warm-up, and we are warming up with this because pretty soon we're going to need it. We are going to find a product. You will notice that when we find the product, every single equation here will have a squared in it because right now we're doing quadratics, which are squared. So let's find the product. The first one, I have two different ways you could do this. We could use a grid method, or we could use FOIL distributive method. I'm going to show you both. I'm going to show you both. Seriously. Okay. So the FOIL method that you all were yelling out only works for a binomial times a binomial. So I'm going to not call it FOIL because then it works for everything. What I'm going to do is I'm going to take the first number, 2x, and I'm going to multiply it by 3x. So 2x times 3x is 2 times 3, x times x. 6x squared. Then I'm going to take the 2x and I'm going to distribute it to the minus 7. So 2x times a minus 7 is a minus 14x. After that, I'm going to take the minus 5 and distribute it to the 3x. So that's minus 15x. And then I take the minus 5 and distribute it to the minus 7, which is plus 35. Then I look for any like terms. I combine my like terms. So I get 6x squared minus, when I add these together, I have 14 x's, 15 more x's. So now I have minus 29 x's. What I'm adding didn't change. The number in front changed. And then I've got plus 35. So that is the so-called FOIL method, or the distributive property, which is what the FOIL method is. There's also a grid method, which is a box method or a table method, however your teacher said it before. This is what a lot of people who are more visual like, but either way works. So what you're going to do, we've got 2 terms times 2 terms. So I'm going to have a 2 by 2 grid here, or box. On one side, I'm going to have the 2x and the minus 5. On another side, I will have 3x and the minus 7. And so we multiply. It's kind of like multiplying area. We do 3x's times 2x's, which is 6x squared. Then for this box, I'm doing 3x times minus 5, which is minus 15x. I do 2x times minus 7, which is minus 14x. And then in the fourth box, negative 5 and negative 7 is positive 35. Oh, yeah, it's totally the same exact thing. It's just a different method. You see it differently. And so you're going to have to add common terms, like terms, which I've got negative 14x's minus 15 more x's. So I get 6x squared minus 29x's plus 35. Thank you. So it's the exact same answer. You can choose your method. So now we go to the second warm-up question. Now you can choose your method, but your method needs to be one of the 2 methods I just did. If you don't do what I'm about to do, this is wrong, and there's bad consequences for what I'm about to do. If you say, oh, squared, and do x squared plus 9, you will kill a puppy. That's what my sign says up here. If you distribute that squared, a puppy dies. I killed a puppy. So stop doing it. I just did for the sake of saving 20 more puppies.
You just killed a puppy, though.
But for the sake of saving 20 of them.
You just said you had more, like, more.
Yes, because I don't want 20 of them to die. You guys are the other 20. All right, so your choices are, you either write it twice and then do that distributive FOIL method, or you make a box and you put the x plus 3 on both sides because we're doing the same thing. X plus 3 times itself. I have the answer because Criswell can do it in her head. Ma'am, but yes. Make sure you can get the same answer.
I got the same answer.
Oh, I got it.
The box method is so much easier.
You like the box method?
It's so easy.
It's you know, whatever you choose. As long as you can get that correct answer. All right, next one. Number 3. Do not kill a puppy. Your dog might be the one that dies then.
Okay.
Oh, that was so mean.
What?
He said okay. Might have to email his parents about that.
Come on.
So if I multiply 3x and 3x, I get 9x squared. 3x minus 8 is negative 24x. I get negative 24x here, and I get positive 64. I combine my like terms. And that's the ones we're going to do for today. When we do our notes next time, the other 3 will be the warm-up. Huh? What?
There's a 3 in the front.
Oh, okay. Well, I'll go over it next time. We're just not going to spend our whole day on something that's.
But you said that's our warm-up.
Yeah. It's for coming up. It's not for today's. It's not for today's lesson. Okay, vertex form is the start of today's lesson. Today's lesson should go somewhat fast. Vertex form is not filled out. We're going to fill it out together. The vertex form of a quadratic function is this. I'm just going to write it bigger. F of x equals a times x minus h squared plus k. This is the vertex form. Now, in this form, h comma k is the vertex. We talked about vertices last time being in our parabola, that point right in the middle that doesn't have a mirror. So we can find the vertex of our parabola immediately if the equation is set up in vertex form. What you'll notice also about vertex form is there is no, oops, I meant to change colors. Right here, there is no reflection in the y-axis, and there is no horizontal shrink or stretch. If it's in this form, you will not have a number in front of that x other than 1. Okay? If it is in that form, you can see HK, vertex, done. We know where our vertex is. Okay? Go to the next page. Now, complete review over horizontal and vertical translations. I'm not going to take time in class, but if you need a review, I can help you individually. Example 1, describe the transformation represented by g of x equals x plus 4 squared minus 1. Then graph each function. We're going to identify the vertex, axis of symmetry, and the y-intercept. It's what you were doing for your assignment yesterday. Okay, so that's due tonight, yeah. Let's describe, oh yeah, I uploaded on my computer. I could find almost all of the answers because in the past I've done things differently. That's okay. I just need to upload the entire paper. I didn't have the paper at home. I wrote a note on there. I have it over in my answer keys. I just need to upload that. Maybe I'll do it during lunch today. Anyway, back to this. Let's describe the transformation. So looking right here, what transformation or transformations do we have? Amelia. What to the left? No. What's the special fun word? Translate, yes. Translate left 4 units. And what else, Amelia? Do you not have it in front of you?
No, I was writing that down.
Oh,
and then down.
and down 1 unit. Thanks. So translate left 4 units and down 1 unit. So this is in vertex form. We can write the vertex. So the vertex is HK, but in the formula here, I'll write the formula right above it. The formula f of x equals a times x minus h squared plus k. So the formula is take away the h, add the k. So because it's take away the h, it's exactly what we've been doing, where you like look at opposite of plus 4. So opposite of plus 4, because it's going to the left 4, what's the x part of our vertex? -4, because it's going left 4. The x part of our vertex is -4. The y part of our vertex, it's the same thing we've been doing with transformations. It's common sense. If it says -1, it's -1. It's the same number. The x part is opposite, the y is the same. So that's our vertex at -4, -1. So I'm going to go plot that. 1, 2, 3, 4, down 1. Okay, so there's our vertex. Our axis of symmetry, I'm pretty sure we came up with like a trick yesterday. What is it, Marin? X equals -4, because the axis of symmetry is x equals, and then we take the x coordinate from the vertex. Or another way I could explain it, it is x equals h from our formula. X equals h. So over here I go to x equals -4, and I'm going to draw a vertical line. That's what x equals looks like. X equals -4, vertical line. And then the y-intercept. So I'm going to have to graph it before. Well, I don't have to. Let's do it by hand. Then I'll graph the thing at the end. Yeah, we're going to do by hand. So the equation is, I already forgot. There it is. Okay, so to find the y-intercept, we always do the same thing. Always we make x 0. To find the y-intercept, we make x 0. So in my equation, I say g of 0. That means plug in 0 for x. Make x 0. Here it is. 0 plus 4 squared minus 1. So 4 squared minus 1. 16 minus 1. 15. My y-intercept is 0, 15. Can I what? Yes, dear.
Do you need the parentheses?
Sometimes. For this one, I didn't, but sometimes, so I always do it. Okay. Okay, so I can graph that. That's not going to fit on my graph, so maybe we want to change the, what's it called, like scale. What should we count by if we're going to hit 15 on the y-axis? 5s? Meh. How about 2s? 2, 4, 6, 8, 10, 12, 14. Too bad I already did it. Yeah, there you go. It's hitting there. at 15, I counted by twos. You know how everybody can tell that I counted by twos is I labeled a couple of them. On my x-axis, I counted as ones, so I didn't label anything because that should automatically mean I'm counting as ones. Now, if I have that one, there's also a mirror point. 4 over from it. There you go. I didn't even have to do any work to get that one. So we've got our y-intercept. We have a mirror point. I am requiring for you to get full credit on graphs that you graph. I'll write it up here. You have to graph minimum 5 points. Okay? Graph minimum 5 points. How many points do I have so far? So I need 2 more. That really only means I need work for 1 more. It really only means I need work for 1 more because it will have a mirror.
So wait, a mirror can't be an individual point?
Okay.
That's 3 with a mirror. And I need 5. So I'll have 1 more point and its mirror, which will make 5 total. Okay. So let's see. Since I haven't learned much more, there's a couple different ways I could do this, but since we haven't done a whole lot of learning yet, let's just plug in a number. Let's plug something in that is not x equals -4. That is not x equals 0, because I've already plugged those in. Something in between that I don't have a point at yet. Something around that middle line that I don't have a point for yet. What x value, anybody, would you like to plug in? Pick something easy. Okay, 1 and 3 are positive numbers.
Negative.
Now, I could plug in 1, but it might be way off the graph.
-15.
I mean, you already have.
Okay, -3 would be good. -2 would be good. -1 would be good. -5 would be good. -6 would be good. -7 would be good. What sounds the easiest to you? Okay, you all have different opinions. Plug in your own then. I'm going to do -1, and it sounds like, I think that was Dominic who yelled that out. We're doing -1. You guys can do whatever one you want because we should still have the same graph. So I'm going to plug in -1. I'm plugging it into the original, so we'll have parenthesis, -1 plus 4 squared. I do like the people that might have said plug in -3 too. I think that one might have been a good one. -1. And then I just simplify. I've got 3 squared minus 1. So 9 minus 1 is 8. So this order pair I just found was -1, 8. So go ahead and graph that. What? And then that has a mirror point on the other side of the axis of symmetry. Where did the what come from? 3?
Yeah.
-1 plus 4 is 3. Did somebody take me up on it and try a different number? Oh.
That looks like a lot. Those points.
Is shy really the right word? Let me just do another one. Let's pretend somebody was like, oh, I'll show her. I'll plug my own number in. And did -3 plus 4 squared minus 1. So that would be 1 squared minus 1, which is 0. So -3, 0 should also be on the graph. And that has a mirror point there. Yeah. So when you have enough points that you can tell it is a quadratic, it is a parabola, then make your U shape. I should be able to see your y-intercept, your axis of symmetry, your vertex on the graph. Yes, dear.
Is that first point going up, like the first, is that going over 5?
Is the first point what?
Like the pink one. Is it
The vertex or the other two?
the other two?
What are they doing what?
Going up 5.
Oh, I messed up my vertex. Because I plotted my vertex before I decided I was renumbering. Thank you for asking. I have my vertex incorrect. I mean, I have the correct answer, but I have it graphed incorrectly because after I had plotted the vertex, then I decided to count by twos. So if I was counting by ones to start, my vertex should be actually here. So I guess it's good to decide what you're counting by before you start graphing.
Yeah.
So you don't make a silly mistake like I did. Okay, let's try a different one. Okay, I am going to do, we're not going to do all of them. I'm going to do one of these. Trying to decide which one I want to do. I was going to do number 2. Number 3 and 2 are very similar. Ooh, I kind of want to do number 1 though, but okay, let's do this. Let's write the vertex and AOS for number 1. We don't have to go all the way through and do everything. Number 1, we need to know what the vertex and the axis of symmetry is. So remember, the formula is going to be f of x equals, if you write it more often, you will remember it, a times x minus h squared plus k. We need to know the vertex. So we look for the hk. The h is going to be opposite like it always was when we're doing transformations. So h is 3, k is 0. Good. And that means our axis of symmetry is x equals 3. The y-intercept, we plug in g of 0. So we get 0 minus 3 squared, which is negative 3 squared, which is 9. And we write it as an ordered pair. Okay, number 2. We need our vertex. Evan, our vertex. What is the x value of our vertex? I'm on number 2. I'm on number 2. What is the, well, I'm circling, I don't know if you can see my little cursor moving. What is the x value of the vertex? 2 is correct. What is the y value of the vertex? Who's giving him information? Like he can't, no. No, if you tell somebody to answer when they haven't even tried, you're telling that person you don't have faith in them. And that's rude.
No, I already knew the answer.
Okay, that's good. I'm not saying anything bad about you, Evan. I'm saying I hear people answering when I specifically wanted to hear from you. And I thought it was rude that they were doing that. Sorry, negative 2. Jason, axis of symmetry. You're missing part of it, huh? X equals 2. If you don't have that part, it's getting marked wrong. Y-intercept, we do g of 0 equals, then we plug in 0 minus 2 squared minus 2, and we simplify. So I get negative 2 squared minus 2. So I get 4 minus 2. And we have a y-intercept of 0, 2. I'm going to use this one to graph because I want to show you. On the last one, we just like picked points to plug in to find more points. I want to show you a different way of doing this one that I usually use a lot. So vertex 2, negative 2. So that's my vertex. My axis of symmetry is a vertical line that passes through that. There's my axis of symmetry. I already know my y-intercept is at 0, 2. So that means I can find my y mirror point. So what I do a lot of times, is there a stretch or a shrink in front of this guy? No, and it opens up because there's not a negative sign. So this is the parent function, just moved. So because we spent all that time learning the pattern, here I am finding more points because I know the parent function. For real though. I'm trying to make it as easy as I can on you. Okay. So let's do this one. We need the vertex first. I'm calling on somebody. Gabby, can you repeat the first number?
5.
Okay, the first number is not correct, but the second one is. Why is it not 5? Anything horizontal?
Oh, it's negative.
It's negative 5. Good. Now, that means our axis of symmetry, Sterling. Okay, I'm going to sketch a graph up here, Sterling, to help you. If I have a parabola, and this is my vertex, my axis of symmetry is part of the vertex, or goes through the vertex, not really part of it. So right here, I erased it. There we go. Right here is this negative 5, 1. What is the x value at the same place? So we write x equals negative 5. So if I have that vertex sitting down there, none of you should miss the axis of symmetry. It's the same number. The y-intercept, we will do g of 0. So I'm going to plug in 0 plus 5 squared plus 1, which is 25 plus 1, which is 26. Daniel, how do I write my answer? 0, 26. Very good. And then if I had 0, 26, I would need to scale my graph differently. So I'm not going to graph that one because you guys can plot points. I just wanted to go over the top part. Then there's some reviews on reflections, some reviews on horizontal stretches and shrinks. And then we're going to describe the transformation, graph it, identify the vertex, axis of symmetry, and y-intercept. So I'm not going to graph every single one of these. We'll graph B. We're not going to graph A. Let's look at it together. I need the vertex. Anna. Thank you for whoever yelled at, but Anna. So our vertex, do you need the vertex form again? Do you want me to write that? So the vertex form is, we're going to find HK. Okay, so the H is whatever's adding or subtracting to the X. What's added or subtracted with the X inside the squared? What'd you say?
I don't know.
Because you don't know because like because there is nothing there. Like, do you see up here how it says X minus H and then quantity squared? Do we have that here? No, because what number would be added or subtracted from X? Nothing. Okay? So if it's just an X squared, the H is 0. So Anna, what's the K? It's whatever's added or subtracted outside of the squared. So it is 0. This vertex is right at our origin. Our axis of symmetry, Darren. X equals 0, exactly. Our y-intercept, Kendall. G of 0 equals And wherever you see the X, make it 0. So what's that? 0. Yes. The y-intercept is 0, 0 for this one. Okay. Remember, the y-intercept is when x is 0. So if I already knew my vertex had x as 0, then I already know my y-intercept has to be that as well. But if you don't notice it, you can still plug in 0. All right, let's do this one, including a graph. So we need the vertex. Let me write that equation again. F of x equals a times x minus h squared plus k. We need the vertex. Megan. It would be 0, 1. Yes, that is correct. Now, just so you guys know, one thing that we wrote when we wrote down vertex form is that vertex form cannot have a horizontal stretch or shrink. So technically, this is not vertex form. What I'm going to do is I'm going to factor out the 2. So it would kind of look like 2 and then x. This doesn't change much. It doesn't change much. It does later, but for this one, it doesn't change much. So at that point, I don't have anything with the x, so then I know it's 0. I think we could have told, like, she obviously got it, and I'm pretty sure you didn't factor, right? Yeah. So I knew you could do it, but we just have to remember that the vertex form does not actually have that 2 in it. But it doesn't affect our answer for this. Okay, our axis of symmetry. Shaq. X equals 0. Good. So let's find our y-intercept. We do g of 0. So we do parenthesis 2 times 0 squared plus 1. 2 times 0, 0. So 1. 0, 1. And that is the same as our vertex. So we're going to graph this one. Vertex at 0, 1. X equals 0. How many points do I need? How many do I have? Okay, so I'm going to have to do a little bit more work. Since I need so many points, I'm going to make a transformation table. We've done this before. X, Y. My x's are -3, -2, -1, 0, 1, 2, 3. Y's are 9, 4, 1, 0, 1, 4, 9. What do we have here? We've got, what's that 2? Horizontal shrink, what are we multiplying by? 1/2. And then the plus 1 is a translate up. So I've got my transformation table set up. I multiply all my x's by half. So I get -3/2. We get -1, -1/2, 0, 1/2, 1, 3/2. And my y's would be 10, 5, 2, 1, 2, 5, 10. So I'm going to graph -3/2, which is -1.5, 10. -1, 5. -1/2, 2. Now, I only need 5 points. I got 7. There's nothing wrong with having more than you need. But now I can connect those and draw a decently accurate U shape here. Okay, so we've gone over now 3 different ways of finding other points. You could just plug numbers in to find more points. You could use a parent function if there's no stretch or shrink and just dot those up, or you can make a transformation table. That's 3 different ways you have to graph these. And then there's some more practice, but probably not going to do that because of time. So your assignment is 10 graphs. When you go to the module, you'll see when I open the assignment, it's actually like Oh, it says bad gateway. Great. Try that again. It's a page from the book, and I just screenshotted questions. There we go. So this is the assignment, and then like literally these are just screenshots from the book. So there's just questions for you. And then what I did is I gave you a paper to download. Oops, let me go back. A paper to download and put all your work on. So the second one here, or the third one, paper for the assignment. When you do that one, I've put a place for you to write your vertex, axis of symmetry, y-intercept, places for you to work it out, and then graph it. So if you're doing it on regular paper, make sure that you add in doing the vertex, axis of symmetry, and y-intercept, and you'll need 10 graphs if you're doing it on regular paper. And I do have graph paper up there if you're doing it on regular paper. Okay? All right. Tuesday. No. Monday.